Ready to open your sheet of potato. It's your not the Excel numbers. Yeah. So you have to right. I don't want to try. I'm sure you do. Shall we start? What time do I end? 5. 30 का है ना 30. But Gandhi, you didn't hear who is fired you. No, I didn't take it down and go all over this. In the rain, nobody will hear your Gandhi. Advani, Ruchi is here. Let us find out. I'm going to get it. This is the version, not bad. Okay, everyone's here. Tomorrow, I promise I'm gone. I'm out of here. So, I want to once again clarify, so many people will join. I want to once again clarify, let us not differentiate paradigms of research with quantitative and qualitative. Uh, Everyone seems to be having that problem. So, paradigms of research are more whether you positivist paradigm, you usually measure participants based on a framework or something that is already been defined. Whereas in a interpretivist paradigm, you your analysis emerges from the participant's thoughts, right? Now, even in the now in a positivist paradigm, because you are measuring against something external, usually you have to use inferential statistics, which means you have to use large sample sizes, and there are very mathematical ways of determining the sample sizes so that your research is valid and reliable. So there are mathematical techniques that determine that you use or statistical inferential statistical techniques in most positivist in all positivist research paradigms. But in the interpretivist paradigm, it does not mean you don't have quantitative data. You will have quantitative data. You could do small surveys with teachers or students, and you may have some quantitative data. And usually you use descriptive statistics. So that is what I looked at your Maldives data and Nepal data. It got too complicated for me to do the class with that. So You go back and look at your data. I've just taken a fake data. I've made up some data and I'm going to take this task today. Let's all imagine it. That is all our data. Right? So, this thing is a pain. I'll just offer it. Yeah, we'll go to the next slide. So, what is the most important thing in quantitative data? Who's looking at me? Who's looking at the slides? Data types. Yeah, so basically, you have qualitative kind of categorical data, and you have quantitative data, which is either called interval ratio or categorical data. And what is an example of nominal data and qualitative data? Think of a survey. Yeah. Nationality, yes. Ethnicity, gender, these are all, yes. Demographic data, you're right. So most demographic data is nominal data. Ordinal data is scales. Yeah, scales of data. And it's ordered in scales. So you have the grades, you have status, and your status, or you have Likert scales, right? Different kinds. You have low, medium, high, agree, disagree, in scales of 3, scales of 5. And you obviously have discrete data and continuous data, which is mostly your weight, height, any ratio numbers, and continuous, and any number that counts frequencies are discrete. So why do we differentiate all this data? Why learn all this? Why? You're right, absolutely right. So the analysis, really the math that you do with it, right? What kind of statistics you can get out of ordinal data is different from what kind of statistics you get out of quantitative versus qualitative and all these. Which is why we kind of differentiate these data types, because there's certain things you can do with some data, and there's certain things you cannot do with some data. Yeah, next slide, please. So basically, in the qualitative analysis, and when you have a simple table, you can do, typically you can do univariate analysis and bivariate analysis. Univariate is one variable. You take only one variable, and what can you do with one variable? With one variable, you can do distribution, which means frequency or percentages, right? So you have your data, and you can say number of boys, number of girls, or the subject and teacher, teachers, like that. And you can do percentages of the whole. That is the distribution. The second thing is I have a data set here, and we'll all together work on it after this. So just bear with me for 10 more minutes. The second thing is central tendency, of course, which is mean, median, and mode. So which types of data can you use for mean, median, and mode? Sorry? On what? On what? So you have three. What is the difference between mean, median and mode. Who knows? Who remembers the school math? Mean is the average, right? Everybody knows. How do you calculate the mean? So let's take out divided by n. Okay, let's do some calculations. So I have so I have 23, 76, 52, 45, and 31. What would be the mean of this? Somebody tell me the total, please.
23 plus 76 plus.
I want to answer. And 26. Yeah. In a calculator. She's not used the calculator. Cheating. 27.5. Somebody said N. What is N? Okay. This is, what is this? This is the mean. Okay, what about the median?
45.
What do I do to get the median?
We have to.
Yes, arrange them in ascending order. And therefore, this is the median, right? Now, can I use this mean for qualitative data? Like nominal and ordinal, can I use the mean? No, I cannot. I can use the mean only for quantitative data, or that is interval or ratio data. What about the median? The median I can use for quantitative data, of course, and ordinal data also. Right? What is the mode? Mode is the frequency, which is the highest occurrence of something, right? Highest occurrence of something, and that can be used with all types of data. So when you are doing your calculations, you need to know, like if you have the number of things.
Why median can be used in both kind of ordinal and
It cannot be used in nominal. It can use
ordinal
because of scales, right? You cannot,
or we cannot use the mean.
how can you use the mean? Because it's an average. You don't have it does make sense in the quality, right? You tell me how to use it. You can't. So the mode can be used because it's a count. It's the highest frequency of something occurring. So the mode can be used even with when you count like like gender or different. But usually the mode you use when there are number of categories, not just two categories, right? So if you're doing like, for example, if you're doing the sales of say trousers, and you have different sizes from size, I don't know, 6, 7, 8, 9, 10, 11, 12, then you can calculate the mode, which is, which is the highest frequency, which size
Validated data into quantitative.
can be converted. Yeah, but you can, the mean does not make sense, right? The mean is the average. And you are only giving it a symbol. Instead of giving it a symbol M and F, you're giving it the symbol 1 and 2. It does not, numerically, quantitatively does not make sense, 1 or 2. Because maybe patriarchally you say men are more 2 and women are less 1. But quantitatively, mathematically, 1 and 2 are just symbols. You're just symbolizing with 1 and 2. You're not taking a quantity of it. Does the numerical quantity, there is no meaning. You understood? That's why I don't. That was just taking a dig at all the men silently. Okay, the last is the spread. So it's really the distribution of the data, right? That is, I think you will really fall asleep if we calculate the standard deviation and the variance. And do you know? Does anyone know how to do it? We already have the mean. What is the mean? Rima is going to calculate 227 by 7.
Like 4 by 1.
So what do? You subtract, because this is the mean. You want to see how spread out your data is, right? And your mean is 45. So you subtract 23 from 45, 76 from 45. You get positive or negative numbers. And then you square that, and then you divide it by. Okay. But basically, what this is telling you is how spread out or how close it is. The data, whatever data you're looking at, how is it spread out or is it close? So you know if the mean score of marks of a student, say in a class, is 70, right? You will know the spread. If it is very large, that means people have got very different set of marks. If it's smaller, the standard deviation, then you're saying that most marks are close together, right? Most people have got around 70 there, or a little bit here and there, below, above 70. But if it's very large, that means you have students who've got probably 90, students who've got very less, like 20, like that. So then that's what the standard, the spread tells you. And these are the 3 kinds of, and the range. The range is the upper limit minus the lower limit, right? So it tells you in what range is the marks. So if the highest marks is 95 and the lowest is 20, then you know you're in trouble, because you have students who are getting 20 and students who are getting 90. But if your range is, so you subtract the 2, it's a very large range. But if it's a small range where your highest is, say, 80 and your lowest is 60 or 70, then it's a small range of just 20. So you know your students are kind of progressing in a pretty uniform way in that subject. So those are the kinds of analysis you can make with descriptive data. Next. So what is bivariate descriptive statistics? Now it gets a little bit more complicated. You can do multivariate also. So bi is when you look at two variables. So when a contingency table is, if I look at 2 variables and try and understand the relationship between 2 variables. And typically you can do scatter plots and you can do correlations, which are a little bit more advanced. We will just look up in scatter plots here. Yeah, but I think I'm going to my example. Yes. I want to leave that there. The Thank you. Yeah, it says if you want to truly understand something, try to change it. Right? So that's how we go with action research. So when you all go back, think about this. I really like this quote by the. Okay, I'm going to put the spreadsheet now. Okay, so I have just made up some data here. I want you to tell me what are all the data types we have here. Can you see? Can you increase the no, just put the top one, top row. Just do an escape first. Yeah. So could you have put this in a form and connected this data? So I'm saying this is data I've collected from newly qualified teachers in some geographical area. I don't know, we call our geographical areas blocks. So what are the nominal data types here? Gender. Age is not but it is not category. It's not a range, right? From 0 to 10 like that. Yeah. Subject is also nominal. Yes. Sorry. It is a quantitative data. So rest are all quantitative, right? And mostly the speech. But working hours can be continuous also. For example, what are the kind of questions you can ask? And what are the kind of tables you can make? So it's a very simple table, right? It's got some details of, it's got the gender, age, the subject they teach, the hours they work. I said these are newly qualified teachers, so their qualification exam marks out of 100 are there. And this is the number of journal articles they read every month in their internship, number of magazines they read every month during their internship. And I'm asking the teacher a question: should teachers forego their pension and get higher salary? Okay, and I've asked them to, on a Likert scale of from strongly disagree to strongly agree, a 5-point Likert scale, I've asked them. This is just made up data, nobody's data. So you have ordinal data there, right? The last one is ordinal data. So give me one question you want to find out from this data.
How many females are engaged in mathematics subject? Mathematics.
Okay. Okay. So we've already got to 2 variables, gender and so tell me with 1 variable. Everybody is sleeping. Come on, wake up. Very technical, yes, it is.
What's the range of max obtained by the teachers?
What is the range of
Max. Okay, max.
range of marks obtained by teachers? Okay.
What is the average age of the teacher?
Average age of the teachers. Okay, good. So let's start with the average age of the teachers. The simplest one. How will you do the average age? You all know spreadsheets, right? Yes?
How many
Okay, we won't do it, but we'll find out later. Okay, we'll let me write this question and then we'll solve it. What is the average age? Okay, somebody else ask another question.
How many female teachers are appointed for this particular program? How many female teachers are appointed?
Okay, how many, what is the count of gender, right? Okay, so what is the difference? So let's start with that. How would I use this in spreadsheet to ask this question of how many female teachers are there and how many male teachers, and those who do not want to or not disclose their gender? How will I do that? You know? Yes, ma'am. Okay. So have you used the pivot tables?
Everything was counted.
Have you used pivot tables? Shall we try? So basically, select all these. Can I say here? So I select all the data. Okay, then I select all the data and I say insert, and I insert a pivot table, and I say put it in a new sheet so that we don't disturb this data, right? And what sir asked about the gender. So let's put gender in rows, right? And what do we put in values? We put the count, we want the count. So we put the teacher ID in the count, and here we say summarize by, and we summarize by count. So what do we get from this table? This is a single variable table, right? So the total number of teachers in my survey who responded are 100, out of which 61 are female, 32 are male, and 7 chose to not reveal their gender identities. Yes. Right? So you can also do what is called if you go back here, you can also do what is called a filter. So I can add a filter for gender, and I can say show only female, what sir asked. Right? So with all single variables, you can do this. What other thing can I do with pivot tables? Instead of gender, I can in the rows add, say subject taught. Let's see which are the subjects taught. And because my filter had only gender, it's not showing all 100. But if I remove the filter, so I have the highest number of mathematics teachers, right? Sorry? Oh, there are two mathematics. Maybe I've done some spelling mistake. Yeah, there must be a space there in one of them. Yeah, because I typed it and I made the data up myself. So yeah, so when you see an error like this, you know that there's a problem in the, probably I put a space in one and not the other. So you have to be a little careful with your data. You might find errors like this. Good catch. What else can I do with, what else makes sense in a single variable? Usually it's demographic data that you will do counts of, right? The first part, distribution, and then you can also change the distribution from count to all these, right? You can get some count, average, but obviously all these don't make sense with feature ID.
The subject and then we can use average.
Sorry?
We can choose the subject and then make
And
get the average.
the average, yes. Yes. Now I just did the count of the people. What I can do is I can also see their average instead of doing a count of teacher ID in the values. What else can I add here? Oh, sorry. Too many things in my head to process here, there. Okay. Okay, what else can we do instead of just getting the count of the number of teachers? What else can I get? So supposing I say gender, right? And I put gender in the rows. And I don't want just the count. What else can I try with the data? Let me remind you of the data again. Average of what? Average age. Okay. So then what will I put? In values, I will add age, and in the summarize by average. So the gender, the average age of female teachers is 40.9, almost 41. Average age of male is 38.3. No. Which is the, yes. Yes. There are two variables, right? Gender and age. So you're looking at two variables. Can I send you the spreadsheet and do you want to try it on your own in your computer?
Yes.
Yeah? How should I send it? Telegram? Yeah. Let me just send it from my phone. I have it on. Try some. Graphs, try some different things. Pivot table, yeah. Spreadsheets, not draw pivot charts, yes.